Let me show you how you can deal with this physics problem. It says, show that kinetic energy equals to 1 over 2 mv squared, where m stands for your mass and v stands for speed or velocity. So, kinetic energy, what is the kinetic energy of a body? As I am now, I am stationary, I am still, I am not moving. I have got zero kinetic energy. Once I begin to move with a certain speed or velocity, I will acquire a net kinetic energy. Therefore, we can define kinetic energy as the work done in changing the position of a body from rest. I use myself as an instance. So, when the position of a body is changed from rest, the work done is equivalent to kinetic energy, so that we now have kinetic energy equals to work done. But that's not all. What then is work done? Work done simply means energy transferred. So, if I am not moving, I am not transferring any energy. But as soon as I begin to move, my energy is transferred into this kinetic energy. Therefore, we can define it as when force is moved over a distance. My entire body weight is the force that I have. So when I move over a distance, I am doing work. That is work done, right? As I am now, I am moving. Therefore, I am doing work. So work done is my force, which is my body weight, multiplied by the distance I've covered. Work done equals to force F times distance S. I'm going to use F to denote force and S to denote distance. So we can invariably say that kinetic energy equals to force times distance. We are not done still. Remember that the body is changing position, right? From Newton's second law of motion, we know that the rate of change of momentum of a body is proportional to the force causing the change. Or we can say that the more mass an object has, the more the force needed to move the object. So we can say that F equals to ma. This is the relationship from Newton's second law of motion. The more massive an object is, the more the force you need to move that object. Therefore, we are going to replace the force F here with ma, which stands for mass, m, a, acceleration. So kinetic energy is equivalent to ma times s. I've only replaced this F with ma. So I can call this my equation 1 and call this my equation 2. We are still not done. Remember that the object is changing position from rest to a new speed. Okay, so we're going to use the formula that says v squared equals to u squared plus 2as, one of the Soviet equations. I'm going to set my u equals to 0. Do you know why my u is 0? This is my starting speed or velocity. U is 0 when the object is stationary. When the object is not moving, it has got no velocity. If I ask you now, what is my speed? I have got no speed because I am not moving. So my initial velocity is 0, or my initial speed is 0. That's why u is 0. If u is 0, then we're going to have that v squared equals to 2as. From here, we can make a our subject formula. That means a equals to v squared all over 2s. This becomes my equation 3. You can see what I've done so far. So what I just need to do at this juncture is to replace a in equation 2 with v squared all over 2s from equation 3. So this kinetic energy becomes m from here times a, which is now v squared all over 2s multiplied by s. This cancels out. So we have that kinetic energy is equals to mv squared all over 2, or equals to 1 all over 2 mv squared. This is how to derive this important formula. All right? Please like, share, and follow. I'll see you next time. Thank you.